everyone, it's Alyssa and welcome to You Can Learn Math. So today we're talking about the dreaded 3x3 or 3 variable equations. Anyway, so 3 variable equations are just like it says on the box, something with 3 variables in it. Now if you get one that's just like this, and they're not going to do this, if they gave you just a single equation with 3 variables, can't do nothing with that. You must have 3 full equations. That's why they sometimes call them a 3 by 3. You have to have 3. There's no other way around it. So the biggest thing with these, the takeaway is we've done before, we've done like elimination, we've done substitution, and I will put links in the description below for those. When you have just 2 variables in there for a system of equations. But for this one, with 3, elimination is the one you need to have solid. You may be able to use substitution at some point, but you absolutely, positively will have to use elimination to do these well. Okay, so here's one for you. 2x minus 4y plus z equals 0. 5x minus 4y minus 5z equals 12. And 4x plus 4y plus z equals 24. I'm just going to double check that I wrote this down right, because I actually already recorded this once. And I made a bobble when I copied it over and just had to throw that all out. So that's not cool. Not a fan of that. I'd like to avoid doing that again. Okay, so we have our 3 equations. And they usually will have like a little bracket like this to show they're all a system of equations. So here is the methodology of this. Is you're going to pick any 2 equations you want. It's totally up to you. There's no right or wrong. And you're going to pair them up and use elimination to get rid of one of the variables. After you've done that, you're going to pick 2 different equations from the set of 3 and eliminate the same variable. Those are the 2 key things in this that you have to do. It has to be 2 different pairs of equations, and you have to be eliminating the same variable for this to work. So I look at what the x's, the y's, and the z's all look at. What's going to be the easiest to eliminate? X's, there's no common, to make these line up, you have to get a least common multiple. They have to be able to cancel. I'm going to have to change some to negative. I'm going to have to, change these. If I do these together, make them both 10. These together, make them both 20. There's a lot of multiplication stuff going on. Again, I'm saying this quickly. This all has to do with elimination. If you are not 100% solid on how we do elimination, please go back and watch that other video first. Okay, y's. Ooh, this looks good. 4y and negative 4y would cancel out here, and these 2 would cancel out, 4y and negative 4y. If I look at the z's, are they any better than that? No, they aren't. So y is what I'm going to do. I'm going to pair these up, the second and the third, and then I'm also going to pair up the first and the third and have 2 different things here I'm going to eliminate. So first, 5x minus 4y minus 5z equals 12, and 4x plus 4y plus z equals 24. All right, so there's my 1 pair. Now I have my separate different pair. 2x minus 4y plus z equals 0, and 4x plus 4y plus z equals 24. Now on both of these, they're already set up that they're going to eliminate the y's. So let's add everything together. 5x plus 4x is 9x. The y's cancel out. Negative 4y, positive 4y. Negative 5z plus z is negative 4z, and 12 plus 24 is 36. On my other side, 2x plus 4x is 6x, negative 4y plus 4y cancels out. Z plus z is 2z, and 0 plus 24 is 24. So now it's like I'm starting again, and now I have two equations, and I want to solve for this system of equations like a separate little problem. Now at this point, if you wanted to use substitution, you could. I'm going to continue using elimination because let's just keep it consistent. Why not? And I look, I've got a positive and a negative here with the positive 2z and the negative 4z. It's like, okay, all I have to do is multiply this by 2 and it will cancel out that. So that's what I'm going to do. I'm going to multiply this whole thing by 2, which gives me 12x plus 4z equals 48. Then this just comes down. 9x minus 4z equals 36. Add those together. 12x plus 9x is 21x. 4z plus negative 4z is nothing. And 48 plus 36 is 84. Right, divide both sides by 21. X equals 4. Well, now that I know x equals 4, I'm not going back to the big three. I'm not going up to those three variables yet. I know that x is 4, so I can put it into either one of these two, and I can solve. Okay? So I'm just going to pick it. I'm going to pick the one on the right. 6 times 4 plus 2z equals 24. 24 plus 2z equals 24, minus 24 on both sides. 2z equals 0. Divide by 2. Z equals 0. Ooh! Now I have two of them. X is 4 and Z is 0. That's hard to say. Z is 0. All right, so X is 4 and Z is 0. So now we go back up to the top. X is 4 and Z is 0. And I can pick any one of these three and plug it in. I'm just going to use the first one. 2 times X, again, X is 4, minus 4y plus Z, Z is 0, equals 0. 2 times 4 is 8. Okay, so I'm going to subtract 8 from both sides. I don't have to worry about that 0. And I get negative 4y equals negative 8. I divide by negative 4. Y equals 2. Dun, dun, dun. And there we have our answer. X is 4, Y is 2, and Z is 0. And if you plug these three numbers into each of these equations, all three of them will work. Here's one. 3x minus 4y minus 3z equals 7. Negative 2x plus 5y plus z equals negative 4. 5x plus 6y minus 5z equals negative 1. Okay, so they're being, it's like, let me do my little bracket. Come on, little bracket. All right. So I'm looking like, are there any of these that they're going to cancel easily without me doing a lot of multiplication? Nope. Nope, nope, nope. So I go, all right, fine. And I'm thinking, I'm probably going to eliminate the z's. I think that's going to be the one I want to do. Let's eliminate the z's. Okay, so I'm going to pair, I think I'm going to pair these two and then separately these two. So my first one, I have 3x minus 4y minus 3z equals 7. And then negative 2x plus 5y plus z equals negative 4. To get these two to cancel out, I have a negative 3z. This needs to be a positive 3z. So to do that, I have to multiply this whole thing by 3. So that's going to be negative 6x plus 15y plus 3z equals negative 12. Okay, I just multiplied everything by 3. I'm going to erase that. So now I have my two equations, and I'm going to add them together. It's a little sloppy, sorry. Okay, so I'm going to add them together. 3x and negative 6x is negative 3x. Negative 4y and 15y is 11y. My z's cancel out. And 7 plus negative 12 is negative 5. All right, there's my first one. My second equation, my second pair, I have negative 2x plus 5y plus z equals negative 4. And then 5x plus 6y minus 5z equals negative 1. All right, so I need to multiply this whole thing by 5 to get those to cancel out. So I'm going to multiply it by 5, and I'm going to write it right down here. Everything I'm multiplying by 5. 5 times negative 2x is negative 10x. 5 times 5y is 25y. 5 times z is positive 5z. 5 times negative 4 is negative 20. Okay, so I've multiplied it by 5. And I'm not suggesting you erase this work on your paper. I'm just doing it so it's a little clearer what I'm adding just on this video. Okay, so let's add these together. 5x and negative 10x, negative 5x. 6y and 25y is 31y. The z's cancel out. Negative 1 plus negative 20 is negative 21. So now I have my two new equations, and I'm going to bring them over here. So now I have negative 3x plus 11y equals negative 5, and negative 5x plus 31y equals negative 21. All right, so I want to eliminate again. I'm going to go for the x's. So for this top one, see, what's our least common multiple of 3 and 5? And we want to make them so they cancel out. So one needs to be positive, one needs to be negative. It's going to be 15. Just 3 times 5 in this case. So I'm going to multiply everything on top by a positive 5 and everything on bottom by a negative 3. When I do that, 5 times the negative 3 will give me a negative 15. And negative 3 times negative 5 will give me a positive 15, and they'll cancel out. Okay, so first 5 times everything. 5 times negative 3x, negative 15x. 5 times 11y, 55y. 5 times negative 20, I'm getting ahead of myself. 5 times negative 5, negative 25. All right, our second one. Negative 3 times negative 5x is 15x. Negative 3 times 31y is negative 93y. Negative 3 times negative 21 is positive 63. Okay, let's add these suckers together. Our x's cancel out. 55y and negative 93y is negative 38y. And negative 25 plus 63 is 38. Woohoo! Right, so we divide both sides by negative 38, and y equals negative 1. All that to get y equals negative 1. Okay, so now I take this, that y equals negative 1, and I can plug it into either one of these and solve. I'm going to do that top one. Negative 3x plus 11 times y, and now I know y is negative 1, equals negative 5. Negative 3x plus a negative 11 equals negative 5. So I'm going to add a positive 11 to both sides. Negative 3x equals 6. Divide both sides by negative 3. X equals negative 2. Okay, I'm in the home stretch. I now know that y equals negative 1, x equals negative 2. So I can pick any of these three up here and plug those in. I'm going to go with negative 2x plus 5y plus z equals negative 4. All right, so negative 2 times, I know x is negative 2, plus 5 times, I know y is negative 1, plus z equals negative 4. Put this over a little bit. Negative 2 times negative 2 is 4. 5 times negative 1, negative 5, plus z equals negative 4. 4 plus negative 5, negative 1, plus z is negative 4. Add a positive 1 to both sides. Z is negative 3. Woohoo! And there's our answer. We have all three variables. Okay. So I hope that was helpful. If you have any questions about this, or if you have a specific problem or word problem that you would like to see addressed, please leave it in the comments below. Much appreciated. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.